So today's lecture is about square roots. And before we get into square roots, which is section DSM A9, we're going to look at what's called perfect square numbers. So if I were to take 1 squared, I get 1. 2 squared is 4. 3 squared, and so forth. And grab a couple numbers here. 7 squared, so 9 squared, 11 squared, 12 squared. All right, so these numbers that we created are called perfect square numbers. Now these numbers, when we take the perfect square of these numbers here, they give us nice results. If we take the square root of them. So for instance, the square root of 1 is 1. The square root of 4 is 2. What that square root symbol is asking you to do is what number to the second power will give you 9? What number to the second power will give you 16? And let me drop down a little lower. Let's go the square root of 81 and the square root of 144 is 12. So we like perfect square numbers because they allow us to give a nice result when we take the square root of them. Let's move to our lecture. These lecture notes are located on my Math Lab, document sharing. To get to that, you're going to click on my Math Lab and log in. Click on Course Tools, and then Document Sharing. So in this first slide here, it's showing you what a radical symbol looks like, or your square root symbol, called the radical. And then what's underneath the radical symbol here, that's called your radicand. What's not shown on here, on a square root, as we just saw earlier with those perfect square numbers, if you take a square root of a perfect square number, you get a nice result. Notice we said squared. So we have what's called an index that's understood on this radical symbol, and it is a 2. You will not see the 2 placed there, but sometimes we work with larger numbers than the square root. We may have cube root, which would look like this. All right, but for this case, we're going to be working and focus on square roots for this section. Let's look at our first problem. The thing is to find the square root of 400. And it's, let's see, what number squared is 400? And it is 20. You would like to run a check on that. You would take your result 20 and raise it to the second power. 20 times 20 will give us 400, which is our radicand, the number underneath the radical symbol. So the answer for this one, the square root, is 20. Notice there's no radical symbol in the answer. It is just the number 20. For our next problem, we have a negative square root of a fraction, 1/16. And what we can do with this fraction is to separate the radical symbol. This is called the quotient rule, and it's a little math maneuver that we can do. Make sure you don't drop your negative sign. The square root of 1 is 1, and the square root of 16 is 4. So the answer for this is a negative 1/4. For the next problem, we have a negative square root 81. Once again, we want to keep that negative sign. And we did this one earlier. The square root of 81 is 9. So the answer for this problem will be negative 9. These are typical problems on the My Math Lab homework, so make sure you take good notes and keep practicing. For our next problem, it's a little different. Although it says find the square root, notice it says in the answer area, round to the nearest thousandths position. This is telling us that we will be using our calculators for this problem. So the square root of 14, and we place that in our calculator. And let's see, my calculator is showing me 3 and 7, 4, 1, 6, 5. We have to round this to the nearest thousandths. So I need to locate my thousandths. This is my tenths, hundredths, thousandths. The number to the right, if it's 5 or larger, means that I'll add 1 to my thousandths position. Notice I'm using the squiggly signs, which means approximation. So in rounding this number, I will have 7, 4, 2. So 3 and 742 thousandths would be my result. I believe we have one more just like this one, the square root of 27. Once again, it's saying round to the nearest thousandths. So this is an approximation. It's also indicated in this answer right here after the square root of 27. You have 2 tildes, meaning approximation. 5.1961 is what my calculator is showing. Again, we're going to round this to the nearest thousandths. So hundredths, thousandths, we look to the number to the right of that, and it's going to remain as 6 since 1 is less than 5. So 5 and 196 thousandths would be my answer. So we first started out with identifying perfect square numbers so that we can have a nice number when we take the square root of that. And now the last 2 problems, we are looking at numbers that are not perfect squares, like this 27 is not a perfect square, so that we had to use our calculator and round appropriately. We're working with square roots because sometimes in life we have applications that will use the square root symbol in there. So this is building us up to solve equations and eventually do application problems. So here we go. The next slide is equations. Notice our equation has x squared is equal to 36. And I bet you already have the answers in your head. What number raised to the second power is equal to 36? Well, we can think of 6 times 6 is equal to 36. We can also look at negative 6 times negative 6 is equal to 36. So we know our answers already would be a positive 6 or it could be a negative 6. But to prove this, we can solve this equation. When we solve this equation, we're going to use what's called the square root property. And this square root property allows us to apply a square root symbol on the left side of the equation, also with the right side of the equation. Notice when we take the square root on the right hand side, we have to put plus or minus in front of that number. So the square root of x squared will give us x. We put our plus or minus symbol, and the square root of 36 is 6. So in order to use this, we need to have our variable raised to the second power isolated by itself equal to the number. Then we perform the square root property on both sides of our equation to keep it equal, and then we simplify if we can. Let's take a look at a problem. Oh, another nice problem. You already have the answer. So this is x squared. My x's are not going very well just now. X squared is equal to 100. All right, what number squared will give us 100? So we have x squared already isolated, and we're going to do the square root property. Put in your plus or minus, and take the square root of both sides. The square root of x squared is x. Put your plus or minus sign. And the square root of 100, what number squared gives you 100 is 10. So on my math lab, what you will do is enter this as two separate answers. Negative 10, comma, 10. Notice it says use a comma to separate answers as needed. So on my math lab, you'll enter two separate numbers separated with a comma. Our next slide is showing an application of the square roots, and this is called the Pythagorean Theorem. And in order to use this, we need a right triangle. We know a triangle has three sides, and in this case, one side will be missing or unidentified, and you are to find the missing side. So we have a right triangle. Notice that we have two line segments. Where it's connected at, it has a little square in that corner. That square indicates you have a 90-degree angle or a right triangle, but a 90-degree angle. So the two line segments that are connecting that right angle, they're called legs. So I'll just call this leg A, and this is leg B. And the longest side, which is adjacent or opposite to the 90-degree angle, is the hypotenuse, the longest side of your triangle. The formula we use for Pythagorean theorem is called a squared plus b squared is equal to c squared. A squared plus b squared equals c squared. Or you can say leg squared, the other leg squared is equal to the hypotenuse squared. Formulas listed below are specifically designed to calculate the measurement of one of the sides. So this is for side A, side B, or side C. Now you can use these formulas. I prefer to use the original. A squared plus b squared equals c squared. Now let's look at our first problem. Find the unknown length in the right triangle. So they're telling us we have a right triangle. We have our 90-degree angle. The two line segments connecting to that 90-degree angle are the legs. So I'm going to call this A, B, and here's my hypotenuse side C. Let's set up our equation. Leg squared, 5 squared, plus b squared equals 8 squared. All right, next we're going to perform with order operations. 5 squared is 25 plus b squared equals 64. 8 squared is 64. Now remember, on that first problem, we had to get b squared by itself so that we can perform the square root property. What I'll do next is to get rid of a positive 25, I need to subtract 25. What I do to one side of my equation, I must do to the opposite side. All right, it has to be on the opposite side of the equal sign. So this 25 minus 25 will turn to 0. And that leaves me with b squared is equal to 39. Now that we have b squared isolated, we're going to perform the square root property, which is taking the square root of both sides, adding my plus or minus sign in front of that square root of 39. The square root of b squared is b, put your plus or minus sign, and the square root of 39 is just the square root of 39 right now because we're not going to simplify that further. What we'll do is, since it's not a perfect square number, we will place it in our calculator and get an approximation. Remember, it says up here in the instructions, round to the nearest thousands as needed. All right, so my calculator is giving me 6 to 449. Round it to the nearest thousands. Tens, hundreds, thousands. Looking to the right. 9 is greater than 5, so that means add 1 to the thousandths position. And I'm coming out with 6 and 245 thousandths centimeters, since they gave us units of measurement. So once again, we have a right triangle. We set up our equation, leg squared plus leg squared equals the longest side squared. Simplify, 5 squared is 25, 8 squared is 64. We need to take away the 25 on the left side so that we can get b squared by itself. We're left with b squared is equal to 39. We don't want b squared, we want b, so we have to do the square root property. We take the square root, place it in our calculator, and round appropriately. Let's try the next problem. Find the length of the side of the right triangle. All right, so this case here, this is my 90-degree angle. So I have my two legs, A and B, and the longest side is C. So we're looking for side C. So leg squared plus squared equals longest side squared. 9 squared is 81. 12 squared is 144. And we're going to leave that right-hand side just as is, equals C squared. 81 plus 144 is 225. And now that we have the C squared isolated, we need to do the square root property. Both sides of the equation. Now put this in your calculator, the square root of 225, you should get a nice number of 15. Now although we have two answers, we have negative 15 and 15, this is the length of a side of a triangle, so we are not going to use the negative. We're going to say that side C is going to be 15. All right. For the next problem, it says sketch the right triangle and find the length of the side not given. I'm a very visual person, so I would have drawn this anyway, but it's a good idea for you to draw it out. It says the hypotenuse is 11 and a leg is 10. The length of the side not given, so I will call that my side B. You can call it X if that's what you prefer, does not matter. Round to the nearest thousandths again if we need to. All right, let's set up our equation. We have a leg that's 10, another leg that is unknown, equal to our longest side squared. All right, 10 squared is 100. 11 squared is 121. Again, we need our b squared by itself. So I will subtract 100 from both sides of our equation to isolate b squared. I am now left with b squared is equal to 21. 121 minus 100 is 21. Next, I'll go ahead and apply the square root property to both sides of my equation. And that will leave me b is equal to plus or minus the square root of 21. All right, type an integer. Well, this is definitely not an integer. It says or decimal rounded to the nearest thousand. So we have to place this in our calculator. And it looks like 4.5825 is what my calculator is giving me. Again, round to the nearest thousandths. Tens, hundreds, thousandths. So in rounding, this number 5 is 5 or greater, so I need to add 1 to the thousandths position. So this is going to give me 4.583. Notice it's telling us approximately, so that's a hint for you that we will be placing this in our calculator. All right, so this is a mini application. A little more on the real life scenario. Our next slide is about a tree. Find the height of the tree shown to the right. So when you take a look at this tree, notice in the bottom right hand side by the trunk of the tree, there's a little square there indicating that we have a 90-degree angle. So we're looking for the height of the tree. So we have a right triangle. With this right triangle, we're allowed to use the Pythagorean theorem. Now to use the Pythagorean theorem, we need to identify our sides of the triangle. So this base that's 17, which connects to the 90-degree angle, is a leg. So I'll call this A. My height, unknown, I'll call it B. And the longest side, the hypotenuse, is C. So remember, we have A squared plus B squared equals C squared. A and B are the legs. Let's set up our equation. 17 squared plus B squared equals 36 squared. Seventeen squared, 289 plus b squared equals, and 36 squared, 1,296. We need b squared by itself, so we can use our square root property. So I will subtract 289 from both sides of my equation. That leaves me only b squared on the left side of my equal sign. And 1,296 minus 289 gives me 1,007. And then we have to do our square root property. And the square root of b squared is b, plus or minus the square root of 1,007. The height of the tree is approximately blank feet, round to the nearest tenth. So that's telling us we need to go and put this in our calculator. Plus or minus 31.733, and it wants us to round to the nearest tenth. So the 10th position is where the 7 is at. I'm looking to the right of that 7. And it is smaller than 5, so that 7 will remain. And that's giving me 31 7/10 feet. That's the final answer. All right, this concludes our lecture.